Okay, moving on. So you see that our setup allows us to very quickly and easily uh, try different examples, just like we did in prior lab and lab 2. But this time, every time we attempt to use a component from the library, we will be giving a closer look at the actual structure inside the source code. This is an extremely useful exercise because it's absolutely a realistic situation, because very rarely you program everything from scratch. Most of the time you use other libraries, and obviously at the minimum you should be able to navigate through the header files of these libraries to see what kind of definitions are available, what kind of functions are available, what kind of structures, and so forth. So moving on. The next similar type of object is using lines. So the lines is a structure, and this time it allows to specify multiple lines. So just individual lines, collection of lines. So let's search for this structure inside the corresponding header file. Most of the time we'll be using the uh, graph.h header file because it contains all of these primitives. I press search by Control F. I bring up the search box and I copy and paste the name of the structure. And also notice that in this box I have two options normally highlighted in my searches. The first one says match the case, so that it matches the case exactly, and then the second one says match whole word, which is typically the way I search for things. And so this just gives me a sharper specification in terms of what I'm searching for. So anyways, we have the lines, and lines is a struct of independent lines, and again it derives itself from shape. And what it does, it provides provides a way to construct lines from a collection of points. So instead of just constructing a single line, you can have a longer collection of points to construct the line, to draw the lines. Let's take a look at the sample that we have over here. Right? So we have the sample of lines, and again, this is lines right here, and we attach it. So let's change it in our code. I'll just probably just get rid of the prior exercise and continue with the latest to keep it simple. So the line object is called X. How about I change it to lines? I don't like single character variable names. So call it lines. Okay, like this. And then attach lines, something that looks like this. So let's see. Horizontal and vertical line, now part of the same structure. And I shouldn't have gotten rid of that color, I think. So let's anticipating the faint appearance of the default color, I would like to say lines dot color. Set color, I think, was the call. Set color, and we'll just say color black. I think we've used this and it worked. So let's try building it like this. So same two lines appear over here, and we have drawn them now as part of a single structure. So you have a choice to use multiple line structures, or you can construct bunch of lines from points. So for instance, if I wanted to play a little bit more here, so I could add more points. So if I also wanted to add something like, 100, 100, 150, and 350, and 500 right here, right? Something like this, just to see what that might look like arbitrarily, just throwing it in. So this is my line right here, which is like extra line added, and now it appears to be like diagonally going even beyond the original size of the window. But you see that it actually appears to be inside when I resize the window. And so it's okay, and it's not restricted that if the window can be resized, it's possible to allow shapes to be drawn even outside of the actual space currently occupied by the window itself. So normally, windowing system of our library automatically clips the extra parts which should not be visible um, at any given point. So that's the responsibility of the library, so that we don't have to worry about these coordinates being always inside the current window. So this is quite nice, right? So we just kind of like try to draw what we want, and then if the user wants to resize it, they can resize it without having us worry about locations of these primitives, because the primitives will be visible anyways. All right. So this takes care of this demo. So we're doing fine with these demonstrations. And so once again, the highlights of the line structure, if we look at it, like just let's make lines visible again. Okay, so we're talking about the structure lines, and let me resize my window right here so that we can see this side by side. Okay, so the lines, uh, the highlights part of the chapter of this book say that lines is a structure that is derived from the shape. So this is here, it's deriving from the shape. Other way to say it is that lines inherit from shape, or lines is a kind of shape, or shape is the base class of lines. So those four statements are all true, and they have the same meaning. So as I say, chapter 14 describes it as to be one of the key points of the object-oriented programming principles, that basically you can reuse classes by simply inheriting from them and expanding their functionality, or modifying, in some cases, their functionality by adding your own parts to the base class and modifying them the way you like.